Warm greetings to everyone and Dr. Josefino. I am Cheryl Ocampo with my group mates Alicia Eusebio, Alexa Amparo, Rainy Abarisha, and Erlin Ganga reporting on the study of Shimazu et al. Entitled Dietary Patterns in Cardiovascular Disease Mortality in Japan, a prospective cohort study.
Let us begin with a brief background of the study. The traditional Japanese dietary pattern was associated with an extremely low risk of coronary heart disease or CHD, but a higher risk of stroke due to the high consumption of salt and low consumption of animal fat and protein. However, this has changed over the course of time. For 40 years, the average consumption of fruits, dairy products, eggs, and meat has increased with the high consumption of while the high consumption of vegetables, soy products, and fish remained constant in the Japanese dietary pattern. This resulted in a decrease in stroke mortality rate. The CHD rate still remained lower compared to Western countries. Thus, it was observed that the Japanese diet may contribute to lower cardiovascular disease or CVD mortality. Initially, studies used single item foods to study their relationship with cardiovascular diseases. However, results became inconsistent. Thus, dietary patterns instead of individual food items were studied. There have been studies of how Japanese diets correlate to specific cancers and all-cause mortality. However, no research has been conducted on the association of CVD to Japanese dietary patterns. Hence, this research aimed to identify the contemporary dietary patterns among the Japanese using factor analysis. This was to investigate their impact on CVD mortality in a large-scale population-based prospective cohort study.
What has been done by the researchers to solve this gap? The researchers carried out a self-administered 40-item food frequency questionnaire, or FFQ, between October and December 1994 to all Osaki National Health Insurance, or NHI, beneficiaries of ages 40 to 79, with 95% response rate. With this, an exclusion criterion was implemented that led to a total of 40,547 participants as the study population. FFQ asked about the average frequency of consumption of each food within a year. Specifically for rice and miso soup, the number of bowls was asked. The frequency of alcohol consumption by drinkers and non-alcohol beverages was also required. By using the standard tables of food composition, nutrients were calculated from the 3-day diet records and grouped into food codes. Proc factor procedure in SAS version 9.1 was used for data analysis. To determine dietary patterns, factor analysis was conducted using daily consumption. To determine the number of factors that should be retained, eigenvalue, scree-test, and factor interpretability were performed. Additionally, factors were rotated by an orthogonal transformation using the Varimax rotation function for a simpler structure with greater interpretability, and an additional sensitivity analysis of dietary pattern derivation was performed. As follow-up, the paper identified deaths from cardiovascular disease, coronary heart disease, total stroke, and cerebral infarction, and ICH by reviewing the death certificates filed at NHI and coding by trained physicians according to the ICD-10. Cox proportional hazards regression analysis was conducted to calculate the hazard ratio, or HR, at a 95% confidence interval and to adjust for potentially confounding variables. More so, dummy variables were utilized for the quartiles of each dietary pattern score, where the lowest was the reference category. Using two-tailed p-values for linear trends, the interaction between sex and quartiles of each dietary pattern score was tested. Moving on, multivariate models were adjusted with the following variables: age, sex, smoking status, walking duration, total energy intake, body mass index, and history of hypertension. Importantly, all analyses were repeated after the exclusion of participants who died in the first 3 years of follow-up. An additional analysis covering only those who were able to perform vigorous activity was also conducted to minimize any possible bias caused by physically inactive participants.
The study correlated different food items into dietary patterns. Soybean products, fish, seaweeds, vegetables, fruits, and green tea were positively associated with the Japanese dietary pattern. Meanwhile, the animal food pattern correlated mostly with various animal-derived food like beef, pork, chicken, and butter. Coffee and alcoholic beverages were also common in this diet. Lastly, the DFA pattern was highly loaded on dairy products, margarine, fruits, and vegetables, although rice, miso, and soup and alcoholic beverages had negative loadings. The dietary patterns varied in the amount of food and daily nutrient intakes. In the Japanese dietary pattern, the participants consumed a high amount of fish, with the highest quartile being around 96 grams and soybean at 101 grams. A high animal food pattern was associated with high fat and meat intake at 41 grams and 34 grams respectively. In contrast, an intake of 268 grams of dairy products is associated with high DFA dietary pattern. However, the Japanese and DFA dietary patterns share similarities in the amount of vegetables and fruit intakes. The only difference between the two dietary patterns can be observed in the high intakes of sodium, fish, soybean, seaweed, and green tea in the Japanese diet. However, in the association of the cardiovascular disease mortality and dietary patterns, the multivariate hazard ratio for the Japanese pattern is at 0.73, while the animal food pattern was reported to be at 1.22, indicating an increased risk. And it is noted that the DFA dietary pattern was not associated with CVD mortality. The study also investigated their association with CHD and stroke. A 0.80 hazard ratio for CHD mortality for the Japanese dietary pattern indicates a decreased risk, while the HR for the animal food dietary pattern was at 1.50. Similarly, Table 3 shows a significantly lower HR for the Japanese dietary pattern with regards to total stroke, cerebral infarction, and intracerebral hemorrhage mortality, but the opposite can be said for the animal food pattern.
The factor analysis was able to identify 3 dietary factors. The Japanese dietary pattern was associated with a decreased risk of CVD mortality, while the animal food dietary pattern was associated with an increased risk of CVD mortality, and the DFA dietary pattern showed no association. These patterns and results were consistent with previously reported patterns observed among different Japanese populations. To add, the Japanese dietary pattern has similar characteristics to the known healthy dietary patterns in Western countries, including high consumption of vegetables and fruits. However, it has been considered to increase the risk of cardiovascular disease. The Japanese dietary pattern was related to a higher sodium consumption and a higher prevalence of hypertension. Although some components of the Japanese diet increase the risk of hypertension, other components may compensate for this and decrease the risk of cardiovascular disease. Components unique to the Japanese diet would include soybeans, seaweed, and green tea, but the effect of these foods on cardiovascular disease risk has yet to be clarified.
The use of factor analysis has strengths and limitations. It can overcome the multicollinearity of various dietary variables. However, it also requires several decisions about the methods used for extracting initial factors in rotation. And even after sensitivity analysis, the dietary patterns were essentially unchanged. 3 limitations were found in this study. First, the healthy behavior that adhered to the Japanese dietary pattern could have confounded the association between dietary patterns and mortality. Although data was adjusted using measured potential confounders, they could not completely exclude the effects of unmeasured confounders. Second, 12% of the participants were lost to follow-up. However, this portion did not vary across the quartiles of each dietary pattern score. Therefore, the researchers considered it unlikely that association between each dietary pattern and CVD mortality was substantially distorted by the effect of loss to follow-up. Lastly, the FFQ used did not ask about the individual portion size and preparation of foods including added oil. However, this may be non-differential and would tend to result in underestimation of impact of dietary patterns.
In conclusion, the study was able to show the association of the 3 food patterns in cardiovascular diseases. Firstly, it was seen that the Japanese diet decreases the risk of CVD mortality despite the fact that it included high sodium intake. On the other hand, it was shown that the animal dietary pattern increases such risk. Lastly, it was shown that the DFA dietary pattern had no association with CVD mortality. That is all for our presentation. Thank you so much for listening.